Dear friends, this is Dr. Muhammad Umar, Assistant Professor from the Department of Civil Engineering. Today, I have came up with a new topic, that is properties of surfaces, and today we will see how to find moment of inertia of a section. So in this video, we'll learn the steps to find moment of inertia of a section. We'll see a solved example, and in that we'll see the trick to find the centroid and moment of inertia of a section easily. So let us see the trick first. Steps to solve first. First we'll choose the axis. Okay, so in order to find the moment of inertia of any section, you have to choose the axis. So it is better you should choose y-axis as the leftmost and x-axis as the bottommost. The second step is divide the given complex section into least number of components for which the centroid and area already known. So this is very important. You have to divide it into least number of components. Simple components for which you already know the centroid and area. The third step is you have to draw the table. This given table you have to draw, and you have to find the required things mentioned in it. So that we'll see while solving the sum. Then you have to apply the formula to find the centroid about x and y axis. Okay, so this formula we have to learn x bar equals sigma ai xi divided by sigma ai for finding centroid about x-axis, and for about y-axis we have sigma ai yi divided by sigma ai. Similarly, apply the formula to find the moment of inertia about x and y-axis. So these two formulas we need to remember. So the trick how you can remember these two formulas is for ixx you will have sigma ix plus this part will be y minus y bar whole square. So this is y bar and this is x bar. Similarly, for the y portion or for the y axis you have sigma iy plus x minus x bar whole square. So sigma ai x minus x bar whole square. Okay, so let us now solve a sum, and we'll see how easily we can solve it with the help of the tricks and the steps. Okay, so in this problem it is asked to find the moment of inertia about the centroidal axis for the given section. So here we'll find the centroidal axis first, and then we'll find the moment of inertia about that axis. Here in this case we have a section which is given as a 3D. So no need to worry about such sums. So these types of sums can be easily converted to 2D as I have done over here. All the dimensions here are in mm. Once you have made it into 2D, you can divide these sections into simpler sections. Here I have converted or divided into simpler components, which is the first one is a rectangle, then second one is also a rectangle, and third one is also a rectangle. So these three rectangles for which we can easily know the area, find the area and its centroid. So like that you have to divide. So this is the first step. So this apart from that you have to choose the axis. So here I have chosen the axis y-axis and x-axis. So x-axis is the bottommost and y-axis is the leftmost. Other things already given in the question. Now let us start solving by drawing the table. So I have already drawn the table here. So I have divided this into three components. So we have component 1, 2 and 3. Okay, other things given in the table. So we'll go one by one. So first we'll find the area. We already know the area of a rectangle is length into width or breadth, you can say. So for component 1 we have 30 as width and 70 plus 30, 100 as length, so we have got 3000. Similarly for component 2 we have 30 as width and 140 as the length, this one, so we have got 4200. So these all dimensions are in mm, so here I have written the dimensions also, so this you have to take care. So for the component 3 we have 30 as width and 170 plus 30 is 200 as length, so this we have got 6000. The summation of all the above we have got as 13200, and this is in mm square, that I have already written at the top, so no need to write it again and again. So this is the easy part, so I will just move fast in this. The second part is a typical part, so here I will try to spend more time, so please be attentive over here to listen. So here I will tell you the trick how to find the centroid of any section or component easily. Okay, so the trick here is that to find the centroid about x-axis, you have to find it horizontally, means you have to measure it horizontally, this first thing, and you have to measure it from y-axis. It should be measured from y-axis, we have already decided. Okay, so we'll see that first. So for this section, okay, so let us suppose here you can see that the centroid of a rectangle will be at the middle. Okay, so we'll assume that the centroid is exactly at the middle. Okay, so to find the centroid of this section about x-axis, so we have to measure it horizontally, means like this, and it should be from y-axis. Okay, so y-axis is this, so we'll be measuring this from this, so this will be my x, and okay, so now this will be b by 2. Okay, so this, suppose this total is 100, 70 plus 30, so this part will be b by 2, which will be nothing but 100 by 2, which will be nothing but 50. Okay, so that's why I've got 50 here. Similarly for component 2 is this. Okay, so change the color. Component 2 is this, so somewhere here I will have the centroid. Okay, so this part I need to calculate from about x-axis, so it should be measured horizontally from x, okay, from y, sorry. So y-axis is this is my centroid. Okay, so about along horizontally we have to measure, and from y-axis, so this will give me the centroid of component 2 about y-axis, and this will be nothing but 30 by 2. This is 30, this from here to here it is 30, so this will be 30 by 2, and this is nothing but 15. So we have got 15 over here. Similarly the centroid for third component, okay, about x-axis will be somewhere here, so we'll assume that it is somewhere here at the center of this component. Okay, so we'll measure horizontally from y-axis, so y-axis is here, and from y-axis it will measure, it will be this one. Okay, so this will be total component by 2, means this total is 200, total length of this component horizontally is 200, and this will be 200 by 2, which will give me 100. So we have got 100 over here. Okay, so like that we have got the centroid about x-axis of all the section. Similarly we'll calculate the centroid of all the section about x-axis. Okay, so now what is the trick over here about x-axis? We need to measure it vertically, sorry. So we need to measure it vertically, and it should be measured from x-axis. We have assumed should be measured from x-axis. Okay, so let us see how. So for the first component, this here we'll have centroid. Okay, so we'll measure it. We need to measure it from x-axis, means from this axis, and vertically. Okay, so this should be measured vertically and should be measured from x-axis. Sorry. Okay, so now we need to calculate these distances. Okay, so how we can do that? So this part, how much it will be? This part will be half of this, because this will be at the center, so this will be 30 by 2. This will have 15. This total is 140, so plus 140, and this part from here to here it's already given 30, so plus 30. So if I will do summation of this, we'll get 185. Okay, similarly for component 2, we'll have so we'll have it from here, so we'll measure it vertically and from x-axis. Okay, so this will be the centroid about y-axis for component 2. Okay, so what will be this distance? This distance will be just half of 140. Okay, so this distance will be just half of 140, which will be 70, plus this distance, this part is already given as 30. Okay, 70 plus 30 will give you 100. Okay, similarly last one, okay, so last one is component 3. So component 3, again we know the centroid is here, will be here somewhere. Okay, at the center, so it should be measured vertically from x-axis. So this will be my centroid or this component. So this will be how much? It will be 30 by 2, which will be nothing but 15. So we have got 15 over here. Okay, so I hope you have understood this critical part of this sum. Okay, and understood how to apply the trick also. Let us move further. Now this part is easy. So we just need to multiply this AI for this. Okay, so we have this 3000 AI into 50. So if we'll do this, we'll get this value. Similarly, AI into YI, so 3000, AI is 3000 into 185. So if we multiply, we'll get this value. Similarly, we can get it for this and this component, and we can do the summation, because this we need it at the end. Okay, so once we have done this, we can find sigma x bar and y bar. Okay, so what will be x bar? X bar value formula we have already seen, sigma AI xi divided by sigma AI, and this will give me 813,000 divided by 13200. This will give me the value as 61.6 mm. Okay, so this we have already calculated. I will just confirm. Okay, 61.67. Okay, similarly we can get the value of y bar. So y bar value will be, formula is y bar is equals to sigma AI yi divided by sigma AI. Sigma AI yi is 1065 000 divided by 13200. This will give me 80.7 mm. Okay, so this will give me 80.7 mm. So we have got x bar and y bar, means centroidal axis of this I section. Now we'll calculate the moment of inertia about this centroidal axis, okay, at the end. Okay, so first we'll see other steps. Okay, so now we'll see the trick how to find the moment of inertia, okay, about the centroidal axis. Here also most of the people will get confused, because the formula to find the moment of inertia about x-axis is bd cube by 12, and here for about y-axis is db cube by 12. So here people will get confused which I should do the cube. Okay, so I will give you the trick, and that trick will help you to choose which side you should do cube and which side you should not. Okay, so the trick is, should do cube the cutting edge. Okay, so if you remember this, you can easily able to find the moment of inertia about centroidal axis of any section. Okay, so let us see how. So we have component 1. We need to find the moment of inertia about x-axis, okay, of this component. Okay, so if x-axis, let us suppose it will be like this. So this axis is cutting this edge. Okay, so this is 30. So we'll do the cube of 30. Okay, into other side is 100. This is 100 divided by 12. Okay, so we'll get this. Similarly, we'll see for y. You'll get to understand. Okay, so for y, for component 1, it will be like this. Okay, so y-axis will be vertical, so it will be like this. Okay, so it is cutting this edge, means 100. Okay, so we'll cube 100, edge of length 100 into 30 divided by 12. Okay, okay, I will do it one more for you. Okay, and then I will proceed. So component 2, for component 2 we have okay, for component 2 we have about x-axis. Okay, so this x-axis will be some horizontal. Okay, it is cutting this 140 mm edge. Okay, so we'll do the cube of 140 in this case about x-axis, and the other side, which is 30, so this will be this. Okay, in this case you don't just need to remember bd cube by 12. Okay, if you just remember bd cube by 12, that is enough for you, and just that trick. This will help you to find the moment of inertia about centroidal axis of any rectangular section. Okay, in this case about y-axis, so this y-axis will be like this, vertical. Okay, it will cut this 30 mm edge, so we'll do the cube of 30 mm edge, and this 140 will be like this, divided by 12. Okay, similarly you can do it for this also. Okay, and then you can do the summation at the end, because we need it to find the moment of inertia at the end. Okay, sorry. Okay, so let us move further. So now this part is easy to finding AI x minus x bar. This is nothing but x bar, and this is nothing but y bar, what we have found. Okay, so how we have to do this? Just see, I will do one sample for you. So we have AI. AI is here. AI is this. So this one 3000 will have 3000 into xi. So what is xi? Xi is 50 minus x bar. X bar is, this is nothing but x bar. Okay, so this is 61.6. Sorry. Okay, so 60.6 whole square. Okay, that's it. Similarly, one more I will do it for you. Here area is again 3000 into yi. yi is 185 minus y bar is 80.7. Okay, so like that if we'll do for all, you'll get these values. Okay, and at the end you can do the summation. Okay, so this step I will move faster. Okay, now I have got all the values. Okay, summation of all the values, and this is my x bar and this is my y bar. Okay, now I just need to add it. Okay, so I have formula for IXS, mean moment of inertia of this section about x-axis is sigma ixx plus sigma ai yi minus y bar whole square. Okay, just I need to put the values. Okay, so this summation is nothing but this 753,500. This one I have put it, and sigma ai yi minus y bar is this one 600,98868. Okay, so I will get it in 10 to the power 6. Okay, so we'll just, I can write in a simple manner as 67.634 into 10 to the power 6 mm power 4. Okay, so please take care of units. Okay, most of the people will do mistake in putting the units, so you should make sure that you are writing all the units properly. Okay, similarly for IYY we have sigma IY, which is nothing but 22815000 here, and sigma AI xi minus x bar whole square, which is nothing but 183,71592. So once you will add this, you will get this value. Okay, again I will emphasize, you should take care of the units and the calculation in this, and rest, this sum is very easy. Okay, I hope you would have understood this sum clearly. If you have any doubts, you can always reach out to me. Thank you for patiently listening. Have a wonderful day.